All right, if you're deep in the world of AWS certifications, you know there are some services you just have to know, inside and out. Today, we're going to pull back the curtain on one of the most critical ones, Amazon Route 53. Let's break down how this thing works as the master traffic director for the entire cloud.
So, here's the game plan. First, we'll start with the basics, what I like to call the Internet's phone book. Then, we'll meet the star of the show, Route 53, and see what makes it tick. We'll dive deep into its powerful routing and failover features and check out how it operates on a huge global scale, but also inside your private network. And finally, we'll wrap it all up with a quick exam guide to make sure all these key ideas stick. Sound good? Let's get into it.
Okay, so to really get what Route 53 is all about, we've got to go back to basics. We need to understand the fundamental problem it was designed to fix. And it all starts with this simple idea. The entire internet basically needs one giant shared phone book.
And that phone book, well, that's what we call the domain name system, or DNS for short. It's pretty simple, really. When you type a friendly name like Amazon.com into your browser, DNS is the service that works in the background to look up the actual numeric IP address for that server. It's this simple act of translation that makes the entire internet work, directing your request to the right computer out of billion.
But here's the thing, right? A simple, old-school phone book just doesn't cut it anymore. What do you do when you have users hitting your app from Tokyo, London, and San Francisco all at the same time? And how on earth do you guarantee your app stays online 24/7, even if one of your servers suddenly goes down? This is where a basic DNS just can't keep up, and you need something much, much smarter. And that is where we meet the hero of our story, Amazon Route 53. This is AWS's answer to all those complex problems. It's way more than a phone book. It's an incredibly smart and efficient traffic director for all your applications.
You know, I love this switch and analogy. We're not talking about a passive phone book anymore. Think of Route 53 as a super smart, high-tech switchboard operator from an old movie. It doesn't just look up a number for you. It listens to your request, considers where you're calling from, checks which lines are busy or down, and then actively connects you to the best possible line. So where does all this intelligence come from? Well, it's not just one thing. It's this powerful mix of really advanced traffic routing, domain registration, constant health checks, and automatic failover. And the secret sauce is that it's all deeply, seamlessly integrated with everything else in AWS. That combination is what makes it a real game changer. Okay, let's get into the nitty-gritty. This is where Route 53 really starts to feel like magic. We're going to do a deep dive into its most impressive trick, making smart, automated decisions about where to send every single person who visits your site.
So first up is something called weighted routing. Let's paint a picture. You've just spent months building an amazing new feature, but launching it to 100% of your users feels a little scary, right? What if there's a hidden bug? How can you test it in the real world, but maybe on, say, just a small slice of your users to play it safe? And this is how you do it. This is the beauty of weighted routing. You can literally tell Route 53, hey, send 80% of my traffic to the old, stable version on server A, but send the other 20% to the brand new version on server B. It is the perfect tool for A/B testing or rolling out new code gradually and safely.
Okay, next challenge. Your application is a global hit. Fantastic. But how do you make sure that your user in Germany gets just as fast an experience as your user in Japan? You don't want people waiting around for your site to load.
Well, Route 53 has an incredible solution for this, latency-based routing. It's smart enough to figure out, for every single user, which AWS data center is closest to them in terms of network speed, what we call latency. So it automatically sends European users to your European servers and North American users to your North American servers. It's all about squeezing every last millisecond of performance out of your app.
But what if you need to control traffic based not just on speed, but on a user's actual physical geographic location? Maybe you want to show different content to different countries. Or, even more critically, maybe you have to comply with data laws, like GDPR in Europe, that say user data can't leave the region.
That is exactly what geolocation routing is for. This policy lets you literally draw lines on a map and say things like, all traffic originating from any country in the European Union must go to our servers in Frankfurt. Or anyone from Canada gets routed to our servers with Canadian-specific content. It gives you incredibly precise geographical control.
Okay, so we've seen how Route 53 is a genius at directing traffic to all the right places. But what happens when one of those places goes dark? When a server fails?
This is where Route 53 puts on its other hat and becomes the guardian of your application's availability.
So, in a normal, happy setup, think of Route 53 as a tireless doctor, constantly checking the vital signs of your main server. As long as that server keeps responding that it's healthy, Route 53 sends all your users there. Meanwhile, your backup server is just sitting there on standby, waiting patiently.
And this is the moment of truth. The very second that health check fails, Route 53 immediately marks the primary server is unhealthy, and then, automatically, with zero human intervention, it flips the switch and reroutes every single piece of new traffic to your healthy standby server. This is DNS failover, and it is absolutely key to building applications that can survive an outage without your users even noticing.
So far, we've been focused on directing public traffic from all over the world, right? But the really cool thing about Route 53 is how versatile it is. Its power works at every single scale, from a massive global website down to the private resources tucked away inside your own secure network.
You can almost think of Route 53 as having two completely different jobs. On the outside, it's your global traffic manager, handling all the public internet users. But it also has a super important private role. Inside your Amazon Virtual Private Cloud, your own private isolated corner of AWS, Route 53 can act as your internal DNS. This means your servers can talk to each other using friendly names, like database.internal, instead of having to remember IP addresses. It's all secure and contained within your private network.
Okay, time for a quick lightning round. If you're studying for an AWS exam, listen up. These are the absolute must-know takeaways you'll want to lock in.
Exam tip number 1. At its core, DNS is just that simple translation from a name to an IP address. But don't forget, Route 53 is also a domain registrar. You can buy, manage, and renew your domain names right there in the AWS console.
Second big takeaway, don't just memorize the names of the routing policies. Understand why they exist. Weighted, latency, and geolocation routing are your building blocks for creating applications that are fast and can withstand failures. You combine those with health checks, and you have an absolute powerhouse for high availability.
And finally, number 3. Remember that split personality we talked about? Route 53 operates in two worlds. It's your public-facing director for global traffic, and it's your internal private DNS manager inside your VPC. Knowing that it handles traffic both outside and inside your network is a crucial distinction.
So there you have it, Amazon Route 53. It starts as a simple phone book, but it evolves into this incredibly intelligent traffic director that gives you performance, control, and resilience. Really, the only question left is, now that you have this kind of power at your fingertips, what are you going to build next?